Seeing as though I have nothing better to do, since I can't force myself to draw anything right now, I thought I would begin my video series talking about, well, basically math and physics. But this is more of an intro of, for those of you who want to pursue a physics degree, what courses do you need to take? So obviously, the basics. You need to take algebra, which, by the way, for some reason colleges have split up into 2 or 3 different courses. I don't know why. It's pretty much the same. They're just dumbing it down to where they're splitting it up into 3 courses. But for the most part, if you're in high school, you'll want to take algebra. So either algebra 1, algebra 2, if it's split up into 2 courses. So if that is the case, you need to take algebra 1 and 2. If your high school only offers algebra, chances are it's the full course and it's not split into 2. I don't know, but that is what I'm going to be going off of. So algebra, you need to take trigonometry, and you need to take pre-calculus. Now I would probably argue that pre-cal is not quite necessary to jump into calculus. As long as you have a good understanding of algebra and trigonometry, then you can jump into calculus. But on the safe side, you need to take pre-cal. And if you're in high school, definitely try and take calculus 1. That'll go a long way and you'll get college credit for it. At least if your college recognizes it, which they should. It's an AP course as well, so they should recognize not only did you take the course, but you also passed the AP exam. So if you took the course and you passed the AP exam, you should have college credit for it. At least that was the case for me. And then you're going to take calculus 2 and then calculus 3. Calculus 3 is multivariable calculus, and at the very end, you talk about vector calculus. So now instead of doing integrals with functions, you're doing integrals over vector fields. Now, I don't know if it's just for the state of Texas, I have no idea, but you may need to take calculus 4, which is really just that last bit of calculus 3, that vector calculus portion, and it's expanded into a whole course where you're dealing with more advanced problems. But calculus 4, or advanced calculus as they call it, or advanced vector calculus, those are the names it'll go by. You'll also need to take differential equations. Now the prereq for differential equations, if I recall, is just up to calculus 2. So you of course need to take all the basics up to calculus 2, and then you can take differential equations. I probably need to go back and dig through some differential equations notes before even making videos talking about it, because I did forget the portion where we talked about nonlinear differential equations and some methods for solving those. But I don't know if you'll encounter those methods in your course, but safe to assume you probably will. You'll definitely need to take linear algebra. That will definitely go a long way. It is simple, but it is powerful, because you'll use a lot of linear algebra and a lot of differential equations in quantum mechanics. So be sure you have those 2 courses down. Lastly, you'll probably need to take an elective course. So you can do probability theory or you can take statistics. I think those are the 2 options. I took probability theory. I think that's probably the better option to go anyway. You can just read about statistics in a short little book. I mean, no offense. It's really, statistics is more just dealing with application problems from what I've read. But probability theory also gives you, I think, a lot more to deal with in the long run, so I would recommend taking that course. Then, of course, you need to take physics 1 and physics 2. That's labeled as mechanics or electromagnetism. So mechanics, physics 1, electromagnetism, physics 2. Chances are, depending on what college you go to, you're going to have to take the engineering physics courses, which is just the calculus-based version of mechanics and electromagnetism. Why they even have an algebra-based version of those, no fucking clue. But I learned that the hard way, because apparently taking physics 1 and 2 wasn't enough. You need to take the calculus-based versions. You can tell I was kind of pissed about that, because I just had to retake what I already knew, just applied with applied calculus in there. Then there is the Weed Out course. The Weed Out course is Waves and Optics. I don't remember much from that course other than learning how to solve some basic partial differential equations and learning how to solve the wave equation. Oh, and talking about normal modes and normal oscillations. So that's really it. I might not make a video talking about that much, because again, that was a difficult course for me. But I might try and find the book again and just dive into it a little bit, maybe. So once you've completed all of those courses, you are now taking the upper division physics courses. Now, you can take any of the courses I'm about to list really in any order. You can take classical dynamics. You can take electrodynamics, electrodynamics 1. You can take quantum physics 1. You can take thermodynamics and statistical mechanics. That was actually my nightmare course. There was one course that we took that's really not even necessary, but they might have you take it anyway. It's called Modern Thermodynamics and Modern Physics and Thermodynamics. I think that's what the course was called. And it really is just a bullshit course that they just make you take. I don't know if that will be the case for some of you, but just know if you see that course, it's most likely bullshit. So those are the courses that you can take, in any order. Then, of course, once you take Quantum Physics 1, you'll have to take Quantum Physics 2. And then, I'm trying to remember. From there, you have the option of taking 2 elective physics courses. The electives, for me, at least from my picking, were solid state physics, relativity theory, and quantum physics 3. And they did have a electrodynamics 2 course, but they made that a graduate level course. Can't remember the reason why exactly, but you could take that. It's just maybe your campus or maybe your college has it as a graduate level course, but you talk more about radiation, from what I recall, hearing in that course. I haven't taken a graduate level electrodynamics course, so I couldn't tell you. I dropped quantum physics 3 because it was boring. I didn't like it. So I took relativity theory, which I thought was interesting. You are introduced to differential geometry as well in that course. Then I took solid state physics as well, which was okay. But our professor was nice, but didn't really make the material all that engaging. And some recommended math courses, these are upper division math courses, by the way, but you don't have to take them. But it's recommended, if you go on to do an advanced degree in physics, beyond a bachelor's, maybe looking into taking a course on complex analysis or theory of complex functions and variables is a good idea, as well as taking a course on differential geometry if you decide to study gravitation in grad school, because that will definitely help with relativity. Or you can take partial differential equations, which would help you solve more difficult physics problems. So those are just some recommended upper division math courses that I would say you could take that might help with your studies later on if you go to grad school. But for the most part, those are the courses that you're going to take. For physics 1 and 2, or engineering physics 1 and 2, which I just recommend taking engineering physics 1 and 2 instead of physics 1 and 2. That way you don't have to make the same mistake I made. You'll probably have a lab with those. You'll also have a lab with waves and optics. Oh, and of course for physics majors, you'll have like a senior lab. It's called advanced lab, where really you're just picking experiments and setting them up. Now, my experience there was awful. I'll talk about that later. What else? I think those are the only labs that I had going into my physics degree. Of course, you have all of your other basic courses, your English courses, your history courses. I'm not really counting those because, they say it's to make you well-rounded. I mean, whatever. You're just there for the money anyway. But those are the main math and physics courses you're going to take for your degree. You'll have at least a few physics elective courses you'll have to take. Those elective courses might be quantum 3 or particle physics or relativity theory. That's another pick. Solid state physics is another. Maybe a more advanced electrodynamics course or even a course on mathematical physics. Don't know, because I don't know what grading those are, if they're undergrad or graduate level for mathematical physics and electrodynamics, or more advanced electrodynamics. Don't know how your school operates there, but for now, those are the courses you can expect to take. So that's it for now. I'll probably be back talking about some of the basic math courses. I'll start there and work my way up, obviously starting with algebra. So anyway, thanks for watching.